All right, welcome back. In the previous two examples, we talked about multiplication and division, and now we're talking about addition and subtraction with scientific notation. All right, so let's look at this problem. A, 2.3 times 10 to the 5th plus 6.78 times 10 to the 7th. So whenever we're dealing with addition and subtraction, what we need is we need these powers to be the same. So if you look here, these powers of 10, this is 10 to the 5th, and this is 10 to the 7th. So they have to be the same, and right now they're not the same, right? So what I'm going to do is I'm going to keep this 10 to the 5th, and I'm going to make this 10 to the 7th into a 10 to the 5th, and let me show you how I'm going to do that. So what do we know? First, we have to understand what 10 to the 7th is. What is 10 to the 7th? Well, 10 to the 7th is the same thing as 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6 times 10, right? Now, if I need to write this, let's see, 10 times 10 times 10 times 10, 1, 2, 3, 4, 5. This right here is actually the same thing. 10 times 10 times 10 times 10 times 10 is the same thing as 10 to the 5th, right? Times 10 times 10, right? 10 to the 5th times 10 times 10 is actually the same thing as 10 to the 7th. I'm just grouping these first group of 5 tens together, and then I have these two left over 10 times 10, right? So we're going to use this concept. I'm going to rewrite this. And what I'm going to do, I'm going to write this 6.78, and I'm going to rewrite this. Instead of writing 10 to the 7th, I'm going to write these two times 10 times 10 times 10 to the 5th. Okay, so here is my 10 to the 5th, right? And then here is my 10 times 10 and my 10 times 10 right there. This is the same thing as 10 to the 7th, it's just written differently. Now see how this is going to change things. So when I multiply this by 10, it moves over one place value, right? And then when I multiply it by 10 again, it moves over one more place value. So this right here, this whole thing here ends up being, right? I move over one, move over twice, so this ends up being 678 times 10 to the 5th. Okay, so I rewrote this number. It was 6.78 times 10 to the 7th, but now I have it as the same base as this number over here. And now that they have the same base as 10 to the 5th and 10 to the 5th, I can now, what you do is you just add these numbers. So I'm going to take these numbers right here over to the side, and I'm just going to add them together. So, whoops, sorry about that. 678 plus 2.3, and I have to add a decimal there and a 0. You put the bigger number on top. 0 plus 3 is 3. Put the decimal down. 8 plus 2 is 10. Write the 0, carry the 1. 7 plus 1 is 8, and 6. So when we add those two numbers together, we end up with 680.3 times 10 to the 5th, right? Now, what we have to ask ourselves is this number, is this in scientific notation, is this number between 1 and 10? And it is not, okay? So it's obviously that this number is too big. So to put it in scientific notation, we have to make it smaller. So we can either multiply by 10 or divide by 10. For this one, we're going to have to divide by 10, right? So I'm going to say that we're going to divide by 10 here, and that's going to make it go over 1, but then it would be 68.03, which is still too big. So we're going to have to divide by 10 again, right, to get that 6.803, right, when we divide by 10 and then divide by 10. Then now this number is between 1 and 10, which is perfect. However, we can't just divide by 10. if we divide by 10, we also have to multiply by 10 here and also multiply by 10 here. Okay? So then what ends up happening is this divided by 10 was applied here, but this 10 times 10 times 10 to the 5th, right? So 10 times 10 is really 10 squared. So I think I'm gonna kind of make a line here and go here. So we have 6.803 times 10 squared times 10 to the 5th, and we have the same base, so we can do that product rule. 6.803 times 10 to the 2 plus 5, which ends up being 6.803 times 10 to the 7th. And that is our final answer. Okay, so the key to this one was getting the bases the same, and so we had to rewrite that 10 to the 7th, so it had a 10 to the 5th times 10 times 10, and then have those times 10 be incorporated in this number, and then we added those numbers, kept the same base, and then we had to rewrite our answer so that it was scientific notation. This number is between 1 and 10, and we have our base power 10 right there. Okay, now let's go on to B, and I want you to go ahead and try B on your own. So here's just B. We'll do C together, so just do B. Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out B. When you get done, press play, and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So when I'm looking at this problem, I know that I'm adding, right? So I need the same base, and I don't have the same base. I have 10 to the 11th power and 10 to the 8th. So what I'm going to do is I'm going to rewrite this 10 to the 11th so it has a 10 to the 8th within it, right? So what is 10 to the 11th? Well, 10 to the 11th is the same thing as 10 times 10 times 10 times 10 times 10. It's a lot of 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I'm going to need 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. So this is my 10 to the 8th, and then there's 1, 2, 3 remaining times 10 times 10 times 10. Okay? So I'm going to rewrite this number with this, or 10 to the 3rd power, right? So it's going to be 8.97 times these 3 10s, 10 times 10 times 10, times 10 to the 8th. Okay, because all of this is 10 to the 11th, plus 1.64 times 10 to the 8th. All right, so these multiplies by 10, these are going to, I'm going to multiply this 8.97 by 10 3 times. So when I do that, right, this 10 is going to move this decimal over place 1 time, this 10 another time, and then this 10 a 3rd time. So I'm going to end up with the number 8,970 times 10 to the 8th power plus 1.64 times 10 to the 8th power. Okay, so now I have my bases, my powers, which are the same. So I'm just going to add these numbers up. So I'm going to take this over here. 8,970 plus 1.64, add the decimal and the zeros. I end up with 46.1798. Okay, that ends up being 8,971.64 times 10 to the 8th. Now the question is this number between 1 and 10? Oh, no, not at all, right? So we're going to have to divide this number by 10. So I'm going to rewrite it. 8,971.64 times, well, it's going to be divided by divided by 10 would move it over one place, and I'm going to have to divide it by 10 again. That would be 89, and then divide it by 10 one more time, and that would give me the 8.97164, which is what I need. And if I'm going to divide it by 10 these 3 times, I'm also going to have to multiply it by 10 as well. Times 10 to the 8th power, okay? So when I divide it by 10, the number gets smaller. And so I end up with 8.971.64 times, this is 10 to the 3rd, times 10 to the 8th. So we're going to do that product rule, right, where we just add those exponents. 10 to the 3 plus 8, which ends up being our final answer of 8.971. Oh, whoopsie daisy. That's not supposed to be a 0.64. Let me this is just supposed to be, there's not 2 decimal places. You're probably like, what are you doing? It should just be 64, like that, and this should be 64, and this would be 64 times 10 to the 11th power. 3 plus 8 is 11, and that is our final answer. It's between 1 and 10, which is perfect. So if you got that one right, great job. Okay, let's work on C together. Okay, now C is the same thing. We have to have the same base. Okay, so right now we do not have the same base. This one's bigger, so we're gonna make this one end up having a 6. Okay, so I'm gonna rewrite 10 to the 9th as 10 to the 9th would be the same thing. Hopefully I can do this without, as 10 to the 6, right? And then there would be 3 10s left over, right? 10 to the 6th, 10 to the 7th, 10 to the 8th, 10 to the 9th. Okay, so I'm going to rewrite this as 4.6 times these 3 10s, 10 times 10 times 10, times 10 to the 6, and that's going to be subtracted from 2.75 times 10 to the 6. Okay, so when I multiply this by 10 3 times, it gets bigger. Okay, so it's going to get bigger by 1 loopy, 2 loopies, and 3 loopies. Right, we just put zeros in there, so it ends up being 4,600 times 10 to the 6. Subtracted by 2, and I'm going to just write it like 2.75. I should have wrote that differently. Okay, 4,600. I'm going to give myself a little bit more space, times 10 to the 6th. And then we put a decimal here and 2 zeros times, and then this is 10 to the 6th. So I'm just 10 to the 6th. I'm just kind of making one big subtraction problem here. So then I'm going to subtract, right? This is going to be a 5, 9, 9, 9, 1. 10 take away 5 is 5. 9 take away 7 is 2. Bring down the decimal. 9 take away 2 is 7. 9, 5, 4 times 10 to the 6th. I'm going to move this over here. Times 10 to the 6, right? Now, is this a number that's between 1 and 10? No, not at all. So am I going to have to make it bigger or smaller? I'm going to have to make it smaller, right? So I'm going to have to divide this by 10. How many times? That's the question. So I'm going to have to divide it by 10 one time, and then another time, and then another time. And then, yeah, we'd have 4.597. So that would be perfect. So if I divide it by 10 3 different times, I have to also multiply it by 10, right? So when I divide it by 10, it ends up being 4.59725 times, and then these 10 to the 3rd. 10 times 10 times 10 is 10 to the 3rd times 10 to the 6th. And then I should probably just put a dot like that. And then what do we have? Product rule. So 4.59725 times 10 to the 3 plus 6, which ends up being times 10 to the 9th power. All right. So, and this is between 1 and 10, so it's perfect, right? And we have our power 10 there, so that's scientific notation. That is our answer. All right, so now there's D. I want you to go ahead and try D on your own, okay? Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out this problem. When you get done, press play, and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So I need the same base. This is 10 to the 7th. This is 10 to the 5th. I'm going to rewrite this one as with a base, a power of 10 with 10 to the 5th in it. So I'm going to do that because I know 10 to the 7th is the same thing as 10 to the 5th times 10 times 10. 10 to the 5th, 10 to the 6th, 10 to the 7th. Okay? So I'm going to rewrite this as 1.62 times those two 10s times 10 to the 5th minus 7.36 times 10 to the 5th. Okay, now I'm going to multiply this by 10, so it's going to get 10 times bigger, and then multiply it by 10 again, it's going to get 10 times bigger. So I end up with 162 times 10 to the 5th minus, I did it again. Hold on, I need to give myself a little bit more space here. Okay, 162 times 10 to the 5th minus 7.36 times 10 to the 5th. Okay, so here's my decimal, my zeros. I'm going to have to borrow. This is going to be a 1, a 9, and a 10. 10 take away 6 is 4. 9 take away 3 is 6. I've got to borrow again. That's a 5. That's a 1. 11 take away 7 is 4. 5, 1 times 10 to the 5th. Okay, this is my answer. Now, is it in scientific notation? Is this a number between 1 and 10? The answer is no. Okay, it's too big, which means we have to make it smaller. Okay, so I'm going to rewrite it. We make it smaller by dividing by 10. So if I divide it by 10, it becomes 15.4. But it has to get smaller because 15 is bigger than 10. So I have to divide it by 10 again, which ends up being 1.5464, which is perfect. And if I divide by 10 2 different times, then I have to multiply by 10 2 different times. And then we have our 10 to the 5th here. Okay, so I'm going to divide by 10 2 different times, and that means I'm going to end up with 1.5464. times this 10 squared times 10 to the 5th. So we have the same base, right? So we can do the product rule. To the 2 plus 5, we add those exponents, and we end up with our final answer, 1.5464 times 10 to the 7th power. And that is it. All right. Okay, let's look at a few application problems. Okay, so for E, we have the mass of the moon is about 7.35 times 10 to the 22nd power kilograms. Find the approximate combined mass of the Earth and its moon. So we have the moon and the Earth. Write your answer in scientific notation. And what's the combined, which means we're going to be adding. Okay, we can do that. So I'm going to put the bigger number on top. Well, what we're doing, we're going 5.97 times 10 to the 24th plus 7.35 times 10 to the 22nd power, right? So whenever we're adding or subtraction, we need the same base, right? So I'm going to rewrite this. So I know that 10 to the 24th power is the same thing as 10 to the 22nd power times 10 times 10. 22nd, 23rd, 24th, okay? So I'm going to rewrite this as 5.97 times 10 times 10, right? times 10 to the 22nd power plus 7, and this just stays the same because this already has a 10 to the 22nd power. Okay, so as I multiply this by 10 twice, this number is going to get bigger by 1 and then bigger again. So I end up with 597 times 10 to the 22nd power, and this is added to 7.35 times 10 to the 22nd power. Okay, I'm going to put a decimal and 2 zeros. Okay, so it's just a big addition problem. 0 plus 5 is 5, 0 plus 3 is 3, 7 plus 7 is 14, write the 4, carry the 1, 1 plus 9 is 10, write the 0, carry the 1, 1 plus 5 is 6. Okay, so we end up with our answer here. Now the question is this too big? Is it between 1 and 10? It is not between 1 and 10, which means it's too big, which means we need to make it smaller. So to do that, to make a number smaller, we're going to multiply by 10 or divide by 10. We have to divide by 10 to make it smaller. Now, how many times do we have to divide it by 10? So if we divide it by 10 once, we would end up being 60.435, which would still be too big. So we're going to have to divide it by 10, move it one more place over, which would give us 6.0435, which would be between 1 and 10, which is perfect. So if we divide by 10 on 2 different times, we also need to multiply by 10 2 different times because 10 divided by 10 is 1, 10 divided by 10 is 1. We're really just multiplying by 1. Okay, so for this, we divide by 10 here and here, and that leaves us with 6.0435 times 10 squared. 10 times 10 is 10 squared, right? Times 10, I'll make it to the 22nd power. Okay, so we have the same base, so we have the product rule. That's the cheat rule where you just add the exponents together. To the 2 plus 22. And we end up with our answer. 6.0435 times 10 to the 24th power. That would be the answer. All right. Okay, let's look at F. It says, how much greater is the mass of Neptune than the mass of Venus? Write your answer in scientific notation. So it wants to know how much greater, which means we're going to take the big one, right? We know it's bigger because 10 to the 26th power is bigger than 10 to the 24th. And we're going to subtract them to figure out what the difference is, because if we know the difference between these numbers, then we know by how much greater one is. So we're going to go 1.02 times 10 to the 26th power, and we're going to subtract that from 4.87 times 10 to the 24th power. Okay, now whenever you're adding or subtracting, right, you need the bases to be the same, so I'm going to rewrite this one. So 10 to the 26th is the same thing as 10 to the 24th times 10, which would be the 25th, times 10, which would be the 26th. So I'm going to write this as 1.02 times, these two 10s here, I'm going to multiply by 10 here, and then multiply by 10 again, times 10 to the 24th, right? Minus, I'm just rewriting this because this is already 10 to the 24th. Okay, so when I multiply this by 10, it gets 10 times bigger, which means it moves one decimal place this way, and then I multiply again, it gets 10 more times bigger. So my answer ends up being 102 times 10 to the 20. Oh my goodness, that is not an exponent. 24th minus 4.87 times 10 to the 24th. All right, so I'm going to add the decimal and the zeros. Okay, I need to borrow. That's a 1. This is a 9. That's a 10. 10 take away 7 is 3. 9 take away 8 is 1. Got to borrow from that, making that a 9 and that a 1. 11 take away 4 is 7. 9. There we have it. That is our answer. Now, is it in scientific notation? Is this number between 1 and 10? It is not, so we need to make it smaller, right? And to make it smaller, are we going to multiply by 10 or divide by 10? If you're thinking divide by 10, you would be correct. So we're going to divide it by 10, which would mean it would move over 1, and it would be 9.713, which would be between 1 and 10, which is perfect. It's exactly where we need it to be. So we're going to divide by 10. If we divide by 10, we also have to multiply by 10. And then we have our times 10 to the 24th here. Okay, so we divide by 10 and this number gets smaller, 9.713 times 10 times 10 to the 24th. And this is 10 to the first power, right? So we're doing that product rule. 9.713 times 10. We have the same bases, so we just add those exponents together. 1 plus 24, right? And we end up with 9.713 times 10 to the 1 plus 24 is 25th power. And there we have it. That is our final answer. All right, that is it for this lesson. I look forward to seeing you in the next lesson. All right, bye.